and then maybe here's a table or here's an equation. Is this a function, yes or no, and why? And so what we're going to start today with is one of those things that falls into the category of you are going to see this a lot in this class. We like to talk about domain, not only when we're dealing with functions, but also when we are dealing with logarithms, when we're dealing with exponentials, when we're dealing with polynomials, on and on and on. So we see domain a lot. And as far as just a concept goes, it is a little bit vague. We talk about all the values that x can be, all the possible values for x. So it's kind of hard to, if you don't have a lot of experience with domain, it's kind of hard to come up to a random function and be able to immediately tell me what the domain is. The good news is, at least for this class, there's really only 3 cases we're going to see. I mentioned them in the video in more depth and kind of justified them. But really, there's only 3 cases, with the exception that at the end of the semester, there will be one small adjustment for a 4th case. But don't worry about that. By the time we get to that point, you'll have so much practice that it's like, oh, the small adjustment is very doable. And so those 3 cases, as you could probably tell by this slide, is I'm going to have a fraction. It has to have x in the bottom somehow. So like this does not fall into that case. So I'm going to have a fraction that has x in the bottom. I think that's case 1 on the lecture or the video. I could have a square root. Again, x has to be inside the square root. I think that's case 2. And then case 3 is pretty much everything else. And I say pretty much with the fact that at the end of the semester, there's going to be a small adjustment. And once you get outside of the class, there are kind of other cases. But again, at that point, you'll probably be comfortable enough with domain to kind of adjust for that. So maybe someone who's seen the video or have some experience, how do I find the domain of a fraction? A fraction with something that has x in the denominator, I guess, specifically.
Set the denominator equal to 0 and solve for x.
Yeah, why are you doing that? How does that tell me my domain? You're absolutely right. I'm just kind of trying to, I guess, grasp why that's the goal. Why do we do that?
And I just have based off the video, but it's because your domain will then be every real number except whatever the x value is. So then you get your domain based off of whatever your answer is.
Because it's what I said in the video is always a good answer. The reason behind it is that we're not allowed to divide by 0. That's what we want to avoid. So that's kind of filling in the gaps of exactly what you were saying. We set this equal to 0 to say x can be everything but these things, because we want to avoid dividing by 0, but pretty much got all of it. Okay, so I set this equal to 0. How do I solve this?
You'd factor the equation and set the factors equal to 0.
Perfect. How do I factor this?
Well, x plus 4 and x plus 2.
Yep. 2 things that multiply to get me 8, add to get me 6. Those are x plus 4 and 2. And so then I write my factors as x plus 2, x plus 4. Order doesn't matter. You set it in the opposite order. You are exactly right as well. And then from there, we set our factors equal to 0 and solve. We've seen all of this before at this point.
Yep.
So x plus 2 is equal to 0. 4 is equal to 0. I do some very basic algebra, and I can see that x is equal to 2, and x is equal to -2. X is equal to -2, x is equal to -4. Before I actually look at what I'm doing. Okay. But as we just mentioned, that's not really what I want. In fact, that's the opposite of what I want. I don't want -2 and I don't want -4. And so as far as just explaining things like in regular old English, saying the domain is everything but -2 and -4 is essentially the right answer, but it's not like formal enough. We want to be very formal when we're doing these domains. And so surprise, surprise, we are going to use interval notation. How do I write this in interval notation?
Would X be everything in between -2 and -4?
That is part of my interval notation. So how would I write that?
-4 is less than X, which is less than -2.
Mm-hmm. So with interval notation, I would do -4, -2. Do I do parentheses or brackets on these guys?
Oh, those would be parentheses because it can't include it.
Exactly right. Great. So that is part of my answer. X can be everything between those two values. It could be between -2 and -4. But X can also be everything less than -4. X can also be everything bigger than -2. So I need more stuff on my interval notation. I need more interval notations, I guess. How do I describe X can be everything less than -4? I couldn't hear that. What's up?
Be -infinity to 4.
Yes, -4, but yes. And so I would do -infinity to -4. And remember that we always want to go smallest to largest. So -infinity is smaller than -4. So -infinity goes to the left, -4 goes to the right. And then the fancy math symbol for, oh, that's also part of my answer, or and is U. It's union. So far my solution is everything less than -4 and everything between -4 and -2. And I want to describe everything greater than -2. How do I do that?
-2 to all the infinity.
Perfect. And parentheses. And this format, I don't know how much you did of interval notation and recitation, but this format, if you haven't seen it a lot, is very spooky the first time you see it. But we see this a lot with fractions. Honestly, if you're going to factor, sometimes when you set it equal to 0, you don't have to do a lot of solving. But when you are factoring, like you set it equal to 0, if you are factoring, it's probably going to look something very similar to that. So that's kind of a little bit of a shortcut of, okay, I set it equal to 0, I factored. I'm going to have to be a little bit careful about what my numbers are, but I know I'm going to have 3 different parentheses. I know I'm going to have these 2 unions. Any questions about that first case? Cool. Case number 2. This guy with a square root. What do I do? How do I solve that? We don't do the top. Jackie has a great question. Loved it. So when we're dealing with fractions, we notice here this top, well, I could also factor it. It's a difference of squares, not super important, but I could factor that. The reason that I don't really care about that with domain is I can have anything on top. 0's fine. -3,000 is fine. Anything I put into my numerator for my fraction is cool. That's good. So all of those numbers will be in my domain. My only concern is the denominator because I'm not allowed to divide by 0. That's the big thing. That's the big no-no with fractions. But that's a great question. I'm glad you brought it up. Case 2. Cases where I have a square root, specifically where I have an x inside my square root. Even if you haven't seen the video, what's typically a bad thing to happen under a square root? What is something we don't love to see?
Negative.
Having a negative number.
Yeah, we don't want negatives under our square roots. Yeah, we can probably deal with complex numbers, but when we're dealing with functions, we like to have nice real numbers. So I can't have a negative. So, well, what do? I say, oh, Negatives are bad. So let's avoid them. Let's take whatever's under our square root and say it has to be positive, or it has to be greater than or equal to 0. In this case, 0 is fine. Square root of 0 is 0. That's perfectly okay. And then I just solve this. Nothing too shocking. It's a fairly basic inequality. I would add 2x over. I would divide by 2. If you did it the other way, if you subtracted 3 from both sides and then divided by -2, perfectly fine. But make sure that when you're dividing both sides by a negative number, you flip the sign. I like to avoid negative, so I just moved my negative number over. Great. Now, how do I write this in interval notation? I want to describe all the numbers that are less than or equal to 3/2.
So would it be negative infinity, comma 3/2, and then a closed bracket on that?
Yep, we put a bracket there because x can be equal to the 3/2, and then we're describing everything less than 3/2. So negative infinity up to 3/2. Anytime you have infinity, it's always going to have a parentheses. You're never going to have a bracket on the negative infinity. So that's just something to be aware of. And again, as far as format goes, when we're dealing with a square root, the majority of the time, we're going to have kind of just this one interval notation. We're going to have a bracket on the number because we're always allowed to have 0. And it might be the other way around. So it might be negative infinity up to a number, or it might be a number up to infinity, but it's going to look very similar to this form. So just keep that in your head. When you're dealing with square root, you're probably going to have something of this form. When you're dealing with fractions, you're probably going to have something of this form. It might be a little bit simpler if you don't have to factor. You might only have 2 if you just can have like a x can't be 4 or something like that. Great. Case 3. How do I find domain of question number 3? This is how do you know when to put a bracket? You always put a bracket when you have a less than or equal to or greater than or equal to. So anytime you see that inequality with a little bar under it, bracket on the number.
Is this the one where it's equal, or it's the domain is all real numbers?
Yes, this is the best case. So really you should be checking 2 things. Does this question have a square root with an x in it? No? Cool. Does this question have a fraction, but does it have an x in the denominator like it had here? Nope. It has a fraction, but it's just 27. There's no x in the bottom. Awesome. All real numbers. Or if you really want to write it in interval notation, honestly, I would just accept the words. But if you want to write it in interval notation, all real numbers is negative infinity to infinity. So you could write it like that. Or if you're feeling particularly fancy, and this is probably not going to be super pretty because I'm drawing with my mouse, there is a symbol for all real numbers because we use it a lot in mathematics. We do this big R with a double bar kind of on the left side of it. Oh, that's not too bad. Any of those work. If you write all real numbers, great. If you like interval notation, great. If you want to feel like a fancy mathematician, that's fine as well. And you might be thinking to yourself, oh, Zach mentions time and time again to show all of my work on the exam. The in-class assignments and the discussions are very much a participation grade. Did you do it? Great. We might give you a little bit of feedback. On the exam, show your work. I'm very generous with partial credit. Even if you have no idea what's going on and you write some sort of math for the question, I'll probably give you a point because it just showed me that you tried on the question. So if you come across this question, you might be thinking, wait a second, he showed absolutely no work. He just wrote down his answer. One of these three. He just wrote down his answer. That's true. So if you want to be extra careful, get your partial points, just write, okay, this is case 3. Like that would be the showing your work. Is saying it's not with a square root. It's not with a fraction with an x in the bottom. This is case 3. You get your points. I'd give you full points if you just wrote your answer, but in the off chance that you missed the question, I would give you maybe a point if you misidentified case 3. At least you show me that you're aware there are cases. Any questions about domain? Again, super important concept. There are sections, fully admit that once we kind of are finished with them, we are finished with them. We probably won't see them again. Domain is probably the most talked about thing in this course. Maybe close second would be factoring. We do see a lot of factoring as well. Okay, let's close off this section with, it's called the algebra of functions. And this is honestly, since we've done the difference quotient, this is a somewhat nicer version of the difference quotient. So all we're really saying here is that if we have these two functions, now we're kind of seeing what I meant with function notation. If we have multiple equations, well, it's good to have these different letters so I know which equation I'm talking about. But the entire purpose of why we talk about the algebra of functions is we're showing that, okay, when we have regular numbers, we're allowed to kind of apply the 4 biggies of arithmetic. We're allowed to add, subtract, multiply, and divide. And we're still allowed to do that if we have these weird functions. We're allowed to subtract functions. We're allowed to divide them. We're allowed to add them, subtract them, multiply them, all of the above. And so that's kind of, this is just kind of an exercise confirming that. So if I'm asked to find something like this, that seems like kind of weird notation. We have an f minus a g, and then it looks like we're multiplying by x. I fully get that. But well, this just translates to all I'm doing is subtracting f and g. So this is the same thing as f of x. F of x minus g of x. And then while defining that, we just subtract the two functions. So f of x is 2x minus 1, g of x is x minus 5. It's always a good idea to put a parentheses around the function, so we just make sure that we distribute the negative. So I get 2x minus 1 minus x plus 5. And then I just combine my terms. 2x minus x is x, negative 1 plus 5 is 4. That's my answer. It's x plus 4. I'm just left with that. It's honestly a new function. It feels weird to kind of just leave a lingering x there, but at this point in class, we've seen that plenty of times. But if we are kind of having the situation we are adding or subtracting an entire function, there's a very good chance we'll have an x in the end. And so this is what I'm talking about, that like we've already pretty much done this when we have subtracted the f of x plus h minus the f of x. But it's kind of good to talk about how not only can we subtract them, we can do all of the other pieces of arithmetic. So for b, very similar process. Here I'm doing f over g times x is what it looks like. We're not multiplying, we're dealing with functions. And so we just have to translate this into f of x divided by g of x. And well, honestly, division usually is one of the easier ones because we can't do a whole lot with it. So we would just do 2x over x plus 5. Or 2x minus 1 over x plus 5. Just put the two fractions divided by each other, and I'm actually done. That's my answer. Question, if I were to ask you to find the domain of this function, how would you do that?
Set the denominator equal. Wait, no, never mind.
Set the denominator equal to 0, solve, and then talk about the interval notation of everything but that number. Cool. You might be asked to do that on the in-class worksheet. Okay, now when we are dealing with this arithmetic of x and x, we have to kind of divide or add or subtract or multiply the entirety of the function. If we have a number, we're being asked to evaluate it. So we have two options. I could kind of follow this exact same structure. I could add the two functions first, leave the x in there for a while, and then when I get to this final result, I will just plug in 1 to it. That's one way of doing it. Typically, a more efficient way of doing it is actually finding each piece. So first finding my f of x, or my f of 1, which f of 1 is going to be 2 times 1 minus 1, which is, well, just 1. Not too bad. And then finding my g of 1. Similarly, is pretty easy. Plug 1 into my x for g, and I get 6. And now that I find these two and now that I found these two pieces, I just add them together. So I find that g, or f of 1 plus g of 1 is equal to 1 plus 6, which is 7. This is a very good example of honestly finding the function first and then adding in the numbers is about as easy as what I did. But sometimes when we have multiplication can be a headache, right? We could have to FOIL, we could potentially have 3 terms going on, where this kind of breakdown of finding each piece first and then multiplying tends to save us kind of a bit of a headache. So last example, f times g of 4. Well, plug in 4 into my f, solve. Plug in 4 into my g and solve. Plus 5 equal to 9, and then just multiply them. There's my symbol. Done 963. Everyone good with this? Cool. So that is the end of section. I believe that is 3.3. I'm going to let you practice both of these concepts. Maybe the more important of the two is domain. And then once we come back together, we'll be able to finish 3.4. It's pretty quick. We might have to go through one more concept on Monday before we review, but we still will have the majority of the class to review. Any questions before I put you in your breakout rooms? Okay. Tech. Okay, last thing we're gonna cover today is one of those things that you see it, and typically students are like, okay, that's easy, I get it, I don't really need to practice this concept. And then the old test comes out, and it turns out that a lot of people did need to practice this concept a bit more. So each piece is agreed pretty simple. Each individual question A is not too difficult. Question B is not too difficult. All of them individually aren't too difficult, but for some reason, when we string them together, students kind of get a little bit overwhelmed. So make sure that this is kind of tracking with you as I'm going through. And if any individual thing doesn't make sense, let me know. This is also a good thing to put on a note card and just be like, oh, here's an example. I can kind of reverse engineer that for my actual question. Okay. So first things first, I want to find f of 0 and I want to find f of -6. So we have seen this notation before, we just haven't really seen it with a graph. When I'm dealing with an equation, I just plug in the value and solve or evaluate. But when I'm dealing with a graph, what I do is this guy is going to tell me my x value. So when I'm finding f of 0, what I do is I come to my graph and here's my x values, here's my y values. And where's x equal to 0? Well, it's right here. So I just trace up to my graph. So f of 0 goes to, oh, right there. F of 0 is 3. I look for the y value. So the thing inside is telling me my x value. The thing outside is my y value. So what is f of -6?
Zero.
Or is it -3?
-3, yes, yes. So again, we come to -6 on the x-axis, trace down to my graph. It's right here. Ooh, that's a bad negative sign. Nothing too terrifying. Everyone good so far? Cool. So, well, finding f of 6 and f of 11, very similar thing. F of 6, 1, 2, 3, 4, 5, 6, right here is going to be 0. F of 11 is going to be 1. Nothing too shocking there, just kind of a double up of the question. This is A, this is B. So, all right. Now, is f of 3 positive or negative? So that's a little bit tricky because, well, in the previous examples, we could kind of go to the point. F of 0 is 3. Cool, I actually have a point for that. But here, f of 3, I come to 1, 2, 3 right here. And there isn't a point I can draw to directly. I'll still trace up to my graph, but I don't know what that is. Maybe it's 3.5, maybe it's 3.8, but that's not what the question's asking for. All it's asking for is my graph positive or negative there? Well, it's above the x-axis, so it's positive. What's my answer to D?
it'd be negative, right?
Yeah, so we go to -4 right here, trace down to my graph. It's below the x-axis.
So if we're asking like for f of -2, that would be positive because it's above the x-axis.
Yep. It's really just asking, is my graph above or below? Everyone good with that? Cool. Now, what question E is asking for is it is asking for where is my graph equal to 0? So notice that's very close to what A and B are asking. It's just flipped. It's the inverse of that question. So to figure out when f of x is equal to 0, I find all the x values where y is 0. So, well, y is 0 here, y is 0 here, and y is 0 here. Kind of looking at the second point. So this is going to be x is equal to -3, 6, and 10. Everyone good with that? Cool, cool, cool. Okay. Now for what values of x is f of x greater than 0? So where is my graph above the x-axis? Well, looking at my picture, it's this. And it's this. But I want all the values. I don't want points. So this is kind of the first place where a lot of people lose a lot of points is they write 0, 3, 2, 4, 4, 3. I don't want the points. I want to describe all of those values. So how do I describe this first red region? In interval notation.
-3 to 5.
Yep. Parentheses or brackets. Oh, 6, I think. Right.
Oh yeah, 6, right. Would it would be included, right? So brackets?
It's just greater than. If it were greater than or equal to, it would be brackets, but it's just greater than. So -3, 6 is my first part, but that's not the only region, right? This also a little tiny region is greater than 0. How do I describe that region? Interval notation.
So then you do union, right? And then 10 to infinity.
I like where your head's at, but my graph actually stops at 11. Like there's a closed dot. This is parentheses and this is bracket because I actually touched that value. Everyone good with that? See a little bit more puzzled looks here. If we could do another, I guess, quick example, maybe I could ask you guys for what value is f of x less than 0. So let's do this as an aside exercise. What would be the answer for that?
So
Look,
this is for, okay. Is it for above the x-axis or below?
This one we're just doing a little bit of extra practice, so we want below.
Oh, okay. So for below, wouldn't it be from -6 to -4 on the first part?
-3. We go all the way up to this value.
Okay.
Bracket on the -6 because we have a point on it. Parentheses on the -3. Kind of hard to read. There we go. That's part of it.
then you do union 6, 10 parentheses.
Feel like we feel better about that? Less confused looks?
I do have a question.
Sure.
So if the graph at 11, say, or even at the -6, if it were to continue going past that point, could you say the infinities or would it
Yeah.
just still be, okay,
Yeah, so if it was like this instead, had an arrow, we would write exactly what you were talking about. But in this case, it's a point, so we stop.
okay, thank you.
Good question. Cool. All right. What is the domain of my function? What are all the possible x values my function has or my graph has?
-6 to 11.
-6 to 11 and brackets, because we include the -6. The smallest x value is -6. The largest x value is 11. So -6 to 11. Everyone good with that? Okay. H, what is my range? Now, range, I don't think we've actually talked about in this class. Domain is all of the possible x values. Range is all of the possible y values. So what are all of my possible y values? Or honestly, another way to think about it is what's the smallest y value? What's the largest y value? And then everything in between them.
Would it be -3 through 1?
I agree with the -3.
-3 to 4.
There we go. My
Oh.
smallest value is here. My largest value is here. Okay, 2 more questions. How often does the line, actually just one more, I don't like the rest of these. How often does the line y equal 1/2 intersect the graph? That's another weird question, right? Because when we have, for what values of x is f of x equal to 0? Well, we could just kind of look at the points, right? Okay, y is 0 here, y is 0 here, y is 0 here. I just write down those 3 points. Where here, there aren't any points that have 1/2, right? I look through these, I don't see 1/2. They're all whole numbers on my points. And so to answer this question, well, let's just draw a line. We know how to draw the line y is equal to 1/2. We've talked about that in section 2.3. I'm bad at sections today. Whenever we did lines. So I'm going to graph that. Okay, where y is equal to 1/2. So that's about here. And then let me just draw a line through it. So how many times does that line intersect my graph?
3 times.
1, 2, 3. Yep. Again, deceivingly simple. Make sure you lock down that concept, because when you do it on your own, as far as how the exam's going, a lot of people will miss this question, question F, and a lot of people will miss question K. I will dare say maybe more than any other question. Difference quotient shows up and it's a hard problem, but I feel like a lot of people understand how to do it, where these 2 questions are fairly easy, but kind of trip some people up. Okay, so we might have to go through a couple of things the next class period, but like I said, we will have a lot of time to review regardless. It's not that much. It seems like we have a section and a half, which is true, but really we only have like 1 or 2 more questions of this type with this graph, and then we have 1 more concept. So we'll be able to get through that stuff. So for the last 4 minutes of class, since a bunch of you guys were not talking to each other, the very last thing that I'm going to want you to submit on your worksheet of 3.1 part 2 is just write something about each of your group members. So maybe on the top or the bottom, wherever you have space, right? Austin's really good at making Discord things because you made that for the group. Don't steal that for that group. You have to come up with different things. So just write those things, submit that, and then you guys can call it a day. Any questions in general since last time we'll be together in class? Today, not ever. That was unclear. Okay, cool. Oh, the chat question. Okay, Jackie wants to know what's due. So you turn in 3.1 part 2, but you also have to turn in something that says something about each of your group members. So say this person's in my group, here's a fun fact about them, or just here's something, it doesn't even have to be fun. Here's a fact about them. Do that for each of your group members at the top or the bottom of your page. Cool. Probably bouncing around, but if I miss you, have a nice weekend, everybody.